Ladies and gentlemen, people of the internet, today I will be sharing with you the most impactful Chainlink feature that I am honestly shocked that no one is paying that much attention to. I believe this feature could spark even further adoption of Chainlink and enable smart contract use cases that were once impossible or insecure. Now I know your time is valuable, so let's just dive right into it. Now the feature that I'm talking about is Verifiable Random Functions, or Verifiable Randomness, which is extremely powerful, and it's something that's been missing from developers' repertoire for smart contracts in basically the entirety of the time that they've been around. Now, I believe that Chainlink's implementation of verifiable randomness on demand for smart contracts, which is in testnet for security audit now, will prove to be one of the most impactful additions to the ecosystem in a long while. However, to explain to you why this feature is going to be so impactful, I want to quickly explain to you what verifiable randomness is. A verifiable random function is a programmatic function that outputs a verifiable pseudo-random value and a proof that illustrates the valid calculation of that random value. In context, a verifiable random function would be called to return, say, a random number, along with a cryptographic proof that can be used to validate how the number was generated mathematically. Now, you can probably, off the top of your head, think of a half a dozen use cases that could benefit from random numbers, like smart contract gambling, random NFT attribute assignment, assignment of roles, jobs, and tasks, selection of on-chain development grants, and all sorts of other functionality that requires some sort of randomness to make it work right. In fact, randomness is a core component of countless solutions in the world of centralized tech as well. And in centralized systems, most of the time, random values can be calculated on a server and trusted by that same server with no real issue because, of course, it's under central control. However, in a decentralized environment, you wouldn't want to trust a centralized or potentially tamper-prone source of randomness to serve your application's core functionality, now would you? It makes you extremely vulnerable to tampering at the randomness level. That's where the proof that we talked about comes into play. This proof allows smart contracts to validate that the random value it retrieves from a verifiable random function, or VRF, is in fact calculated properly and not spoofed. Now, in the days of old, many developers used to use smart contract-based randomness that were very, very weak. So things like the latest block hash, which were prone to minor attacks, and obviously even harder to secure from end users who could reverse engineer the randomness function itself to game the system. And this became a real problem for dApp developers who needed randomness in their application and spurred the invention of complex smart contract-based randomness solutions that have varied in effectiveness, but they've worked till now, kind of. There was and still is, though, a clear and dire need for secure, verifiable randomness for smart contracts that won't break the bank. That said, Chainlink has delivered a solution to this problem in the form of an oracle, or an external service that feeds data into a smart contract construct. Chainlink has utilized a verifiable random function framework to provide on-demand randomness to smart contracts, along with the necessary proof to validate its integrity. Simply put, a smart contract developer can import the functionality from Chainlink's verifiable randomness contract, call a request randomness function, which triggers the generation of a random value and a proof from Chainlink nodes for a small fee in link tokens. Then that value is returned to the contract, and if accompanied with a valid proof, the random value is fulfilled to the requesting smart contract for whatever use case it needs it for. Of course, if the proof is invalid or no response is received from the Chainlink node, the supplied value will not be accepted, and the node that failed to serve a valid response can be removed as a provider of randomness, and of course financially penalized in link token revocation because they're not doing the right thing. Granted, verifiable randomness is really not a new concept, and Chainlink is certainly not the first to implement it. However, Chainlink is uniquely positioned to provide this service to smart contracts due to its high degree of integration with some of the most highly utilized protocols in the blockchain space. And this means that on virtually any network, verifiable randomness will be accessible to the native smart contract scripting languages therein. This opens up so many new avenues for smart contract developers, I can't even tell you. Firstly, because it makes randomness far more secure for apps that already use it and already need it. And secondly, it will enable developers to create brand new, robust use cases that were once impossible or wildly insecure to even attempt without provable randomness. So a perfect storm is brewing right now, and I'll have to tell you this candidly. My prediction is that gaming is the first place that this feature really starts to shine in prime time. The new Ethereum non-fungible/fungible hybrid token standard, dubbed ERC 1155, which is developed by Engine, is starting to pick up steam now, and it's a match made in heaven for Chainlink verifiable randomness. So let's just imagine this. Imagine a game developer can implement a non-fungible token contract that's capable of efficiently creating a wide variety of collectible in-game items that have unique attributes. Of course, each item in a class can have unique attributes that are rarer and more common, so they can randomly assign attributes whenever a new item is created using a verifiable random value. For example, in an open world game, random items spawn in the open world, which could be driven by verifiable randomness in a smart contract. Then, to engage its users, a game developer might want to build a daily treasure box feature, where users can once a day open a treasure box and get a random NFT using, of course, verifiable randomness to generate that random item. Of course, this is not possible to do with any real integrity without verifiable randomness. Mark my words, I'm telling you, in 2020, maybe early 2021, we'll see at least one notable game or game developer implementing Chainlink's verifiable randomness for in-game crypto items, or at least in-game logic using smart contracts. This could trigger massive growth for both Chainlink and the crypto gaming community as a whole, not to mention the protocols that these games are implemented on. Of course, gaming is not the only place that this can be applied. There are much more consequential use cases that could utilize verifiable randomness, such as decentralized autonomous organizations, or DAOs. The crux of this type of community, where there are no central authorities or really anything to control what happens inside this community, it's really a community of participants where roles, responsibilities, tasks, and decisions are assigned or made using fair practices outlined in code. Of course, it would not be equitable or sustainable for decisions about, say, which entities take on leadership roles in the organization to be driven by random functions that could be prone to tampering. This would throw the entire organization into disarray and mistrust. However, verifiable randomness could provide means by which every decision or assignment driven by a random selection within the operating model of the DAO could be truly validated as a truly random process, because the proof that comes with each random value can show how it was calculated. As such, no questions or doubt could be cast on the results of such a random assignment. Now, these are merely two powerful examples of how verifiable randomness unlocks both new potential in applications and improved implementations of applications that already exist in the world of blockchain. Of course, all the features that Chainlink has to offer, this is but one that I am arguably the most excited about, and one that I would love to use more myself as it comes towards mainnet release. Now, just think about this in the future as you think about Chainlink as a service that's providing significant value to a lot of different blockchain networks. And of course, leave me a comment down below if you have an idea for how verifiable randomness could be used in either your application or an application that you have in your head. Thanks so much for watching, guys, and don't forget to check out my Chainlink explainer video, which I will link right here on the screen for you to click if you have time to stick around. Thank you so much again. Cheers.